let's just look over there. There's something nice. We all know there is a kind of frenzy around the Apple One, and a lot of Apple One clones have surfaced lately. Or usually they are 6502 machines, except that one. This is a 6800 one. So, Martin, who built it?
Okay. You see here, that is the clock generator for the 6800. Rather complicated. 6502 chosen later was much simpler. All this logic was on chip, so simply plug it in. That one is complicated and it doesn't work at the moment.
What's maybe also interesting here is Martin and his friends are still, stay here, are still part of the Auge, which is the app, or originally was the Apple User Group Europe. These are people from back in the good old Apple II time. Now it's called what? Just Auge. Oh, so no meaning anymore? Come on. We all know what it means. So next one is very nice project. Andreas has recreated PDP-8E, right? Okay, has recreated a PDP-8E from the drawings and put it into an FPGA. So we have basically a PDP-8 running here, just a little bit smaller than usual and kind of faster, right?
No, it's exactly the same speed.
Okay, cool.
The cycles are exactly based on the timings are generated like the original, so we have exactly what is important is one time of this also at this exact full speed. The lights are directly controlled from the FPGA, so there's no slowdown, no subsampling. If it's toggling at 500,000 times per second in the original, then it will be toggling at the same speed here. That was basically the main goal. So not just a front panel computer without having to buy an original one and having space power for that.
Definitely a lovely build, is it? Thank you, Andreas. Up here is something nice.
Yeah.
This is the oldest type, like C64. You need to have a Commodore. And the newest type, ChatGPT. So we're operating ChatGPT from C64.
Yeah. Yes, this setup combines the old. This setup combines the old the Commodore 64 with the newer technology, with an Arduino and the ESP 8266, and the connection between the Commodore is the user port. The user port is the gateway from the Commodore 64 to the Arduino chip, and the Arduino chip contains a client that is connected with OpenAI and the REST API, and it takes the requests from the Commodore 64 to the REST API to the host compute HTTP post request and gets a return the response and bring the response back to the Commodore 64. Yes.
Thank you.
Thank you. So this is Tim. Tim got some real nice mid-90s devices here. essentially the very first fully real-time video processing system based on DC technology, made by Fast Electronics in Munich in, what was it, 95, 96?
Yeah, 95, I think. This package is there. And it's a live vision mixer. You can control it from the software. You can play back video files. You can put titles in. You have different transitions. You can do color keying, chroma keying, luma keying, different effects. And if you look down here, I put a video image into the screen over there, and I can zoom it out and put it back and do different effects like dissolve or something like this, or maybe just do dissolve. This is a captured video. It is around 1250 megabits, kilobits, sorry, and it's played back by video hardware, and I can mix two video sources live, and yeah, add titles and do really great stuff with it. It also features video tuner, and you can view the video sources on the FPGA screen, so on the computer monitor. And this is overlaid, so the video card does the following. The Windows output just displays a black screen in this box, and the movie machine overlays the image onto the screen by yeah, it's like basically loop device through the card, through the video card. And, yeah.
And all in beautiful Windows 95.
And now it's the Windows 98.
Oh,
Sorry,
isn't it way too modern?
It is. So and I displays the video overlay, and so you can see how it works if I open up the application. So video signal goes over the edge. So pretty great technology, and yeah, it still works. And it was like a dream in the mid '90s to get all those video effects and transitions and so on for home video editing.
Really good. Yeah.
Thank you.
Thank you. Tim also did a great speech about all the technology and how to operate it and so on. Not sure, was it in German or English?
It was in German.
It was in German, but it's recorded. So
No.
any
Oh yeah,
not recorded.
He did it. He did it.
It's not recorded, but there is a YouTube video I made, and this is in English. And if you search fast movie machine, or you scan this QR code, you can watch the YouTube video of the movie machine and how it works and what it can do.
Wow.
So have fun with that. Thank you.
Thank you.
Yeah, what's next? Next. Next is a bunch of different trainer systems, all based on Intel 8080s. I think we have to start over there on the left side. And here is Gerald.
Hi.
Who was even designer of some of these systems?
So my name is Gerald. I'm training on this system some years ago, and developed one after the 8085. Now we have here systems only with 8080. On the left side, you see development and training system from NEC. It's a TK80, and it is based for the training system developed in Germany, in Munich, on the training center, 1976, with additional hardware and complete other design of the software of the monitor program. This is the only prototype, and the series system is here. First, it was programmed binary. For example, we have here a reset, 8 switches for address and data. So I can, for example, give here binary the high byte of the address. 8000 is 8 is 0, 1, 3 times 0, 4 times 0. And then I have here with the select switches to go down. Oh, one moment, please. I have to.
Always have your manual handy.
Yeah, address is always high, and then I have to switch here, execute, and now I have here the 80. Now I need the lower address, for example, 50. It's the 5 is 4 and 1 and 0. Then I select, and now I have. Oh, sorry, there's a problem. The system has today some problems with the temperature. 8. Now maybe it's too hot. Okay.
Yeah.
And so you can enter the address, then the byte, and with other selections you can read out the enter, the byte value. If you are good in programming binary, then you can go to the hexadecimal system. You have here the 16 hex Ziffern, digits, and there some
Yeah.
okay, some
It's hot today.
buttons for executing some monitor programs. The next is a complete user new developed system, always on the 8080 processor, and the other what chips for running the 8080 for clock and so on, and demultiplexing, addressing data bus. Then you have here 2 RAM chips, 4 times 256 bit. So we have 256 bytes. Then here the monitor program and a reassembler. There are 2 parallel I/O, 825050. One is for the keyboard and the other for this display. The second is for connecting to additional hardware. For example, like here on the right side, 8 switches and 8 LEDs. Other possibilities are AD converter or EEPROMer. This is, for example, AD port.
What's maybe interesting with this machine, it's one of the Trophy 5 and the 50 are maybe one of the most built and most widely used training systems in the world. They were extensively used in German apprenticeship training, but also in other countries, even way down in Africa and Asia. I don't know how many were produced. Really a lot, really a lot.
With the 1885 was
for a good 30 years, next to everyone in certain jobs had to learn with these machines and also learn to build them, because they were also available as kits. And the students had first to solder their own computer before they could go into a programming course. So this was really fundamental training. Maybe a little reason why there are so many good German engineers, because they had to learn the basics first. So not Haskell, but soldering.
Okay.
Thank you.
Sorry. Yeah, well, this is something much alike Intel. Siemens, who was second source for Intel, also sold kits to show off their chips and to configure a training kit. And this is a very special trainer also from Siemens. I mean, it's not really special, the trainer itself. It's based on standard Eurocard boards, but remarkable is the case. This is the case of a small telephone exchange built in Vienna. Of course, that factory was in Vienna. And the engineers from the factory thought they need a device to train their apprentices. So they came up with this design and used the case of a telephone system. Well, I always thought this is very funny. Thank you. So here's Bernard. Bernard is a very special guy, and he has a very special, rather uncommon American computer.
Yeah, this is
Das Mikrofon.
is this on?
Ja, ja.
Okay. So this comes from DEC Digital Equipment. Used to be a famous company, was later bought by Kappa and disappeared. Well, they were famous for their PDP, personal digital processor, I guess, machines, PDP-8, PDP-12 especially. And those were what was called, well, medium computers, so to say. Also used a lot in industrial control applications. And in this case, they reduced a big box PDP-11/03, one of the models of the PDP-11 series, into a microprocessor, which you see here, the one with the ceramic case. And it was intended for embedded applications. And as usual for CPUs or microcontrollers for embedded applications, you could buy a so-called evaluation board. It looks a lot like a KIM, a SIM, something from that, from a few years later. Small difference maybe, usually with 8085 and stuff, you had hexadecimal entry. In this case, you have octal entry. So, what else can I say? It has two serial interfaces. Yep. Masters. Okay. Okay.
Thank you.
You're welcome.
Wir müssen ja noch die ganze Runde machen. Nein?
So here's something special again.
Hello.
This is a brand new 4040 computer.
Yes, it's
In fact, it's so new, it didn't work until a week ago.
exactly.
This is this is complete wire wrap. This is just the display. And over here is the CPU. And he literally finished it 4 days ago, 5 days ago.
Yesterday, actually.
Oh, I thought you sent me a picture of a
I
working system.
expanded it with a serial port.
Okay, cool.
It's a special general purpose I/O chip from Intel, where a serial port is emulated by software with 2,400 thoughts. And here you can see the outputs. So now it crashed. So now it sends. It has a memory capacity of 1 kilobyte, and you can execute programs from a RAM.
Okay, one question, the usual stupid one. Why?
Because we can.
Yeah, I guess we got a bunch of nerds here, huh?
Yeah.
So thank you very much.
Thank you.
Thanks for having me.
So here's a bit more technology, more modern technology. An SGI Indy workstation, except the disk was dead on arrival. Thank God of faults also. and he managed to use some modern toys to get it up working.
Yeah, our plan, our project was to re-establish the IRIX on that SGI Indy. Normally booting over the web, we tried that. We had a little success, but in the end, we grabbed a CD drive, and now we trying it with a CD and doing the installation and run the Indy again. And maybe the guy who grabbed the CD drive also brought his Octane and Indigo 2, so maybe we expand our project a little bit.
I thought you were using a Raspberry Pi
Yes,
first to boot it from the Raspberry Pi as network boot.
and it worked. One tool was working, and we could partition the drive, but when we tried to start the installation, it didn't work. We don't know why, but we were not patient enough to continue, so we decided to grab the CD drive. Here in the group and with these guys, you can fix everything here.
Well, thank you.
Thank you.
Thank you.
Now, since we just had the modern 32, or was it already 64-bit computers, now we're going back to, what is it? 1, 2, 3, 4, 5, 6-bit computing.
4 and 6 bits. Yeah, that's very little
Without
bits.
any computer, just with Jürgen. Jürgen is the execution unit. This is the memory and the adder unit, and he will tell you how to add with a few balls. Yeah, well, you need balls to do that. Add your balls, right?
So it's, when you say ball, I would say it's a marble machine. Nice marbles where you can add things. So this is an adder unit, and on the back you also see a keyboard where you can enter decimal numbers. Very simple keyboard. You press one of the keys and one of the rods will turn. So that does pretty much nothing except translating key presses into rotation. Connector is here.
It does a decimal binary conversion, doesn't it?
The conversion in the end happens on the next unit. That's the decoder matrix. All the black rods that go horizontal have an intersection with a white push rod that goes forward. And when there is I need a black rod for that. When there's a little lever here on the intersection point, then the rod will move or it will not move. So you can think of that as an OR matrix where incoming gates control the outcoming gates. So that's the decoder from decimal to binary. So let's do an example. You say some small numbers.
3,750.
Small numbers. You need to stay below
17.
17. So I have a 10 and a 7.
Yeah.
If I'm evil, I press them simultaneously. And you get a 17, which is obviously a 15 and an additional 2. That's almost nice, but we have these double. The 2 is twice here. So we use the adder unit to normalize that into correct bit representation.
And now we add 15.
And you also want to add 15. I lost a few marbles here and I need to feed some more. 15 means I have the 10 and the 5. I press them simultaneously again. So that's quite another number, right?
Yeah, I just want to have the result. I don't care about the numbers.
All right, so you know the result already in your head? Good. Memorize that. It's a complicated result. And adding means I have to crank this little lever back and forth, and that operates these shovels, which actually carry a ball. If there's a ball, they carry the ball over the ramp into the next groove. So that's called a carry. Let's do it very slowly. You see some carries happening here. There are a few balls coming out underneath. They were discarded. When you have two balls, one is going down the slot and the other one is going carried. So we see still many balls and there's one double. Although where they have no ball in the top, nothing happens to the balls below because the shovel has a slot and it doesn't touch the pin. So you see here one where nothing does. If I move the pin,
it throws out the ball.
It's only moved when there's a ball.
Exactly. So the shuffle can move without harm, and a 0 stays a 0 and a 1 stays a 1. But when there are 2 in there, then the carry is executed and the ball goes over and this one gets discarded. See that? So the carry propagates very slowly.
Yeah, I know. I've been nasty.
That's good. It's a super nice example. Thank you for that. Very nice, very illustrative example. So we have 216. So now I can guess the result. Oh, and now nothing happens anymore. So the result seems to be 15 plus 17. Oh, that's 32. Yeah, here's the result.
Yeah.
That's a great example. Thank you very much for that.
I especially like the way the numbers are written. Because this is so old-fashioned. This is 16th century fashion, isn't it?
You mean the font here,
Yeah.
the writing? Yeah, I started with the sub-chancery font.
Yeah.
But then I found out that Hermann Zapf is still alive.
Oh,
So that doesn't work.
no.
Yeah, we are in 1700 now.
Yeah.
And I cannot use something that is science fiction here. So I had to go back into the medieval times, find one of the monks that had a scriptorium book, and decimal numbers are really hard to find because everybody spelled the numbers out
Yeah.
or used Roman numerals.
Yeah.
And decimal is Arabic writing. That's very, very rare. But there are a few monks that actually did that. And yeah, this is a little bit older. That's like in the 14th, 15th century.
Yeah. My guess.
Not 17th century. Yeah, it's a bit older. But no, you have to have it. Otherwise, it's wrong.
Very cool. Maybe also to add, the mechanic used here was first described by Leibniz in 17.
Exact numbers 1679.
1679. Wow. Okay. Yeah. He was early.
So that is a page from original Leibniz manuscript. You see a list of decimal numbers and binary numbers side by side. And you see a lot of handwriting. It's Latin mixed with French, but it's so unreadable, it doesn't matter which language it is. And that's the 2 pages that he did as a manuscript, the one here and these 2 pages. Very nice handwriting, and yeah, you can follow his train of thoughts, where he basically says, I found a very simple way to do computations using the 1, which represents everything, and the 0, which represents nothing. So we have God and boy. And that's the philosophy behind it. Reduce all the math on the most simple concepts that you can get.
Yeah. And back then it was the most cumbersome one because nobody would use binary.
And Leibniz himself actually said it might be useful for scientific research.
Yeah.
We use it for number theory.
Yeah.
For discovering patterns, which mean strange arrangement of other numbers.
We do this again. It's called functional programming, and everything is recursive, and everything takes up all CPU time and no result.
Yeah.
But it's proven that it's right.
Right.
Okay.
Jürgen also works in the Fab Lab in Nuremberg
Nuremberg Fab Lab, here we are.
and built some nice machines out of laser cut wood, like this decimal calculator according to Chicago or other similar things, or this is beautiful, an radiator made from wood. I love them. I mean, I love the original ones, but in wood it's new quality. Oh, and some may have seen that the multiplying monkey. Yeah,
Put the feet on the numbers you want to
Yes,
multiply.
10 by 3 is 30.
30, yeah. Now you tell me what is 7 by 7.
7 by idiot.
Wait a minute, I show you. 7 by
Okay.
7 is a square number, right?
Yeah.
Did you find a square somewhere?
Well, there's a 4. Oh, 7 squared. Oh, that's cool. I didn't know that. That is awesome. I love it. I love it. So you got, the whole row is squares. It's
one row of square, extra
one-
row just for the square.
1, 4, 9, 16, 25, 36, 49, 64. Yeah. Yeah. Lovely. Hey. Okay. Didn't know that.
See,
Thank you very much. Thank you.
And remember Leibniz.
Yeah.
He was the first doing binary.
Thank you.
Thank you.
So over here, yeah, this is maybe not as obvious, but this was originally binary. We're a bit too late to read the numbers, but these were little muffins baked to celebrate 10 years of Steckschwein. Steckschwein is a 6502 computer which started life exactly 10 years ago. I think at VCF, or at least around VCF. Yeah, okay, here's the original one. This is the original Steckschwein. Steckschwein translated is maybe like pin pick, because they are just, or plug pick, because they just plugged it together. And it worked. It worked. So the next one was these boards over here. So they tried it to make it with the bus system as single boards, Eurocard form, but their own connectors. And this is the last iteration, all in one board, running at
10 megahertz.
10 megahertz right now, which isn't too slow for a 6502. And as I heard, they just ordered Pac-Man.
Yeah.
I don't know. That's not what it was. Some statistics. Maybe check them.
Okay, sollen wir noch mal Zeit?
Ja, mach doch mal.
Okay, ready for Pac-Man in
Games.
games. So, the first and only. Ist der Ton?
Ja.
Okay, hello. The first and only 6502 Pac-Man, which exactly mimics the arcade version, including the ghosts having white eyes and everything. Also being in portrait format. So it's.
And didn't you? I think I remember you also implemented some bugs.
Yeah,
all
bugs.
It's known bugs. Yeah.
All known bugs are in there. It's the bug compatible version, and it's the definite 6502 Pac-Man version, because all other 6502 Pac-Man are not as close to the arcade as this is, and so there's a installed base of like 2 machines worldwide who can run this version of Pac-Man, and make that extra rare, I guess. Extra cool, maybe. This is not a port; it's a complete re-implementation. For details, ask him.
Yeah.
I'm just playing.
For now, I think it's enough. Thank you.
Yeah.
Stay with the 6502. Andre is a very well-known 6502 tinkerer in Germany. He published a lot of interesting stuff, and over the last few years, he also sold a lot of interesting stuff, including the micropad, which is right here.
Thank you. Yeah, this is the micropad. This is my newest self-built computer. It's basically a 65/8/16 machine with an FPGA for graphics and modern interfaces like USB and Ethernet and so on. And actually, it's a pet clone. And if you If you start it up, you can actually select which kind of pad you want to run. You have several options. It has a lot of additions to it. Like this Ultra version has dual SID. It's got the fast serial for the Commodore disk drives from the C128 or C64. So a lot of things in there. It's got colors. With the help of Steve Gray, who has provided the editor ROM options. Got 512K fast RAM, 512K video RAM, lots of audio options. So check it out. I'm going to present it on my YouTube channel, 8-Bit Times, very soon. And hope you like it.
Thank you. What we have here is, well, whom we have here is Udo Möller. He is a well-known FPGA tinkerer to recreate national stuff. Some may still remember the National 32032 series. We all know there was a 332 and a 532, and there was a 632 planned. Guess who really built the 632? He did. Was one of the projects he had a few years ago. Really nice. All the features National promised, he did build them. Of course, with today's technology. What we now have here is a rebuild in FPGA of an original Series 3 workstation, which is a beautiful beast. But I mean, just look at the keyboard. Just look at the keyboard. It's not just the machine. It's an original 3 keyboard with the large keys. I love them. They are extremely durable, extremely good to type on, and well, unobtainium nowadays. The real point here is the FPGA system over here, where he put in the whole machine with exactly the same functionality. Oh, sorry, your machine.
And here we have the screen of the machine just booting. And this machine has an operating system which is a little bit unusual. For example, if you want to see something of your disk, click here, get a new window, and now you can do, sorry, just switch the floppy. And here you see the content of the floppy, and you can do read on of the floppy. You see here on top the message of it. Now you can take a program here. Let's select this one, open it in the left window. Now you can compile it. Click here, and now go to the end of the program, and you can open it. And here is the Minesweeper, and you can play. So it took only some moments until you get a finished program and let it run. Let's see whether there is a mine. No, not, no. Ah, I hit the mine. Okay, game over. Thank you.
Thank you. Well, after taking the short 3-2 to a 32-bit high power, we're back at the 6502. Some may remember that most originally sold the cheap CPU together with a special 6530 ROM and IO chip as a minimum system called TIM for early hobbyists. Now, Christian here, he did take the original chips and build a new system using all the documentation from MOS. And not only that, he also built an old 1978. What was it? Here's the original paper, 1978 electro terminal. ASCII keyboard plus video interface is writing on your screen. Ooh, high tech, huh? So we have this 1978 terminal. the recreation of a 1975 chipset usage together as a working 6502 computer operating
Paper tape.
paper tape punch. Yes. Oh, guys, sometimes I really don't know what I'm talking.
Bist du losgegangen oder?
Thank you very much. Yeah, great tinkerers. All are.
So,
I think we stop here for the. Oh, wait, we forgot something. Here's the
the
flea market.
treasures.
There's the flea market. You know, half of the people are always over here and digging through the boxes. So we have a few nice things. Well, common stuff like, I don't know, early PC cameras, deck manuals,
Yeah.
tubes. Of course, the usual amount of PC crap. The thing is, I mean, we're all laughing about this PC crap, but it gets harder and harder to find a PS2 keyboard. So
Or a VGA screen.
stupid modern PC is getting old.
Yes, do we.
Duct tapes,
Yeah.
Mega Atari, some Toshiba PCs, Schneider. Is it Sharp? Sorry, Sharp PC. Oh, I want it. It's 188. Serious? 188? That one? Oh, let me have a look.
Hans.
Sorry. Yeah, I love computers.
Ja, machen wir erst. Machen wir erst.
Oh, and then we have a Mac XL for sale. And an original Apple III screen, second disc. For all Commodore printers. So yeah, that's our flea market. Partner.
Jetzt sagst du auf Wiedersehen.
Thank you very much for listening to all of this. And a great hello over to Chicago, and enjoy your side of the VCF.